Okay, so the first thing that we're going to need before we can do any of the needle in the haystack analysis is we need some ticker symbols. We need some historical data. So here's a random set of ticker symbols. I have a couple of them listed here, and I'm just going to pull some data from the internet so that we can see what this would look like. So let me grab this data from Yahoo Finance using this other piece of software that I wrote, what allows you to select the ticker symbols like I'm showing you here. And we're going to go all the way back to 2003. And we're going to do daily data, okay? And then we're going to download the data right over here. All right, let's see how this runs. Here we go. Downloading daily data since 2003. Here we go. Now, this may take up to a couple minutes here. Oh, it's going pretty quick. It might take less than a minute, actually, to just snatch up all this data from Yahoo Finance, like I was saying. And once we have this data set, then we could apply the needle in the haystack stuff. So let me just show you how this works. Okay, so it's almost done here. It's now formatting the data. So over here, what I have is, let me move this chart out of the way. Over here, I have some random ticker symbols for some stocks. Okay, these were completely randomly selected out of a list of like 6,000. I just randomly picked a couple. And then I downloaded some data from 2003 all the way to 2021. I downloaded some daily adjusted closing price data from Yahoo Finance using some other script that I wrote. But here's the format that it needs to be in. The time, okay, the date has to be the first column that you see here, followed by all your ticker symbols, and they need to be matched up in terms of time. So if the first date is November 14th, this would be the price in November 14th of all the stocks in that particular date. You just need to get yourself this body of data, and you would have, for every column, the number of stocks that you're going to be looking at, okay? So here's how this whole thing works. Suppose that I wanted to analyze this particular company right here from column T, okay? So column T right now is this ticker right here, the second to last stock. Now, the reason I picked on this one is because the data set had an interesting shape here. So if I insert a chart, let me put in a line chart for us. This has an interesting shape. So suppose that we want to look up this pattern in the haystack. This is going to be the needle, and we're going to look this needle up in the haystack. So what I'm going to do is I'm going to copy this data set right here, and I'm going to paste it right up here where I have the needle, okay? So I'm going to go just paste the values here. What we're going to do now is we're going to launch the add-in. So assuming that you've already installed the add-in, we're going to press Alt F11 on the keyboard to bring up the VBA module. Then we're going to open up this thing that says Fin Pattern Finder. You're going to click and expand the area that says Forms. We're going to click on Fin Pattern Form so that this pops up on your screen. And then we're going to say Run the subform, or you can click on F5 on your keyboard, and that will bring up this pop-up window. Okay, the first thing you're going to select is the values that correspond to the needle, which is the time series that we're looking up. This is the pattern. And then the haystack is going to be your entire data set. So you can see here, starting with the date right here, all the way down to the bottom of the data set, all of it. So you would just select the entire thing. And this is where we're going to be looking for a pattern. Okay, the output, we're going to stick the output over here into Z1. I'm going to check the checkbox that says the first column has dates. You'll see why in a minute. And I'm going to normalize everything to 100 as my base, and I'm going to find the top 3 matches for that pattern. Let's take a look and see what it finds. Just click the go button. Hopefully everything goes smoothly. Sometimes it does crash if you don't select the data properly. So, you know, it's as you can see up here, this is not a released piece of software. This is still an alpha, and I wrote it a very long time ago. I tried it out a bunch of times and never really used it commercially for anything. So maybe you have better luck with it. Anyway, so it finds the matches, and then we can close the Visual Basic for Applications window. We don't need this anymore, so let's just get rid of this. And here is what it found. So here is the normalized needle, which is this data set right here, but it scales it. It scales it so that it ends at 100, okay? It's still the same pattern. In fact, here, let me show you. So if I click on Insert Line Chart, let's say, and if I move this needle over here, it's the same. You see how it's the same? The only difference between this graph and this graph is that the normalized needle ends at 100. This way, we can look and see what was the closest match. So here is a match. And remember, this was the stock SCHN, and the match number 1 was GE, and here's the time frame from 2018 to June of 2018. And look, that's pretty close. It's not exact, obviously, but you know, it's following the pattern a little bit. And of course, it's not going to find a perfect match because I didn't feed it an enormous amount of data. You know, I could have, you know, going back to 1950, and I can have a list of 6,000 stocks, for example. It's more likely to find a more accurate match than just looking at a handful of stocks going back only a couple of years. So that was the first match. Here's the second match. As you can see, here's the third match. And what we can do here is we can say, okay, what did this orange one do in the past after this time period, right? So this is where we can drag the data down like this, and we can observe and see what happened to it. So as you can see, it follows the pattern and then it went down. What about the next match, MNRO? That continued to rise, but then it fell back down. And the third match kind of stayed flat. So it's not really conclusive, and the pattern match wasn't really all that great in this example. Because the data set that I have here is not inclusive. You know, it's not like a data set with thousands of stocks in it. It's just a handful of stocks. You know, what is this? Like maybe 17 stocks, right? Because you lose the title here. So 17 stocks going back to 2003. Well, imagine 6,000 stocks going back to 1950. If you could download all that data, now let it run all night, download all the data, and then you could probably use this to find anything you want. But of course, the larger the data set, the longer it's going to take to complete the matching. All right, so that's basically how it works. It looks for a pattern and finds the closest match in the data set, and then it says, okay, what happened after that, right? So they meet here. They meet at 100. So in other words, they both get normalized to 100 here, as you can see, right? So they meet at 100. Then the orange one continues. The orange one continues because we have history on that, and we're saying, all right, what is the blue one going to do, assuming that it behaves like the orange one, and so on. So that's the idea behind this pattern matching software, and that is how it works. All right, knock yourself out. Let me know if you enjoy it. Again, the entire thing, though, is you need the data. So you need to get the date, then the different ticker symbols, and they all have to be matched in terms of what was the closing price on that particular day. All right, well, that's how it works. Thank you so much for watching, and I hope this helps. Take care.